Hi everyone, welcome to another interesting lesson. In today's video, we want to take a look at the solution to this algebraic and exponential expression. We are asked to find the value of x. What will be the value of x in 4 to the power of x plus x equal to 0? Let's find the solution. From our question, we have 4 to the power of x plus x equal to 0. Here, 4 to the power of x here is always positive. It implies positive. For the sum of this expression to be equal to 0, then it implies that 4 to the power of x will be equal to minus x. This means that 4 to the power of x is greater than 0 always. 4 to the power of x will be greater than 0 always. Then minus x will be greater than 0 means that minus x must be negative. That already tells us where the solution of x lies, which means that the solution of x lies below 0. So we transform this equation to a special form where both sides become power. Then what we need to do is to consider this expression. 4 to the power of x is equal to x. So from there we can say 4 to the power of x into brackets, this multiplied by 1 to the power of 1 over x, then at the other side minus x also multiplied by the exponent 1 over x. Now this implies that 4 to the power of x multiplied by 1 over x is equal to minus x into bracket to the power of 1 over x. Then we can cancel out this x, and for the left hand side we have that to be 4 to the power of 1, which implies 4, and this also gives us minus x to the power of 1 over x. Now let's define x to be equal to m. This implies that x will be equal to 1 over m. Transforming that into our expression, we can now say 4 will be equal to, into brackets, minus 1 over m to the power of m. So if we write this properly, we can say minus 1 over m to the power of m is equal to 4. We have not changed anything. Now we have if minus x is greater than 0. So it implies that x, positive x, is less than 0, and m is also less than 0. So this implies that from our m, that is from our minus 1 over m to the power of m, which is equal to 4, can now be equal to 1 over m into bracket to the power of m equal to 4. Now this can now be put as m to the power of minus 1 into bracket to the power of m equal to 4. If we multiply with the exponent, we have that to be equal to m to the power of minus m equal to 4. So if we flip this, if we consider this identity, a to the power of minus 1 is equal to 1 over a. If we consider this, then this can be flipped as m to the power of m, which is equal to 4. Then that can be written as m to the power of m is equal to 2 to the power of 2. But we know that 1 over x is equal to m. So, and that will be equal to 2. So it implies that 1 over 2 will now be equal to x. If we replace m with x, so we have this. But since x must be negative, since our x must be negative, so this now implies that our x will now be equal to 1 over minus 2. 1 over minus 2. And this will be our value of x. Another approach to this equation is using this interesting method. If we have 4 to the power of x plus x equal to 0, we can outrightly divide both sides by 4 to the power of x. Then we can see divide by 4 to the power of x, divide by 4 to the power of x, divide by 4 to the power of x. So this cancel out with this, then we are left with 1 plus x over 4 to the power of x, and 0 divided by 4 to the power of x will likewise remain 0. So we can subtract 1 from both sides, then we have x over 4 to the power of x equal to minus 1. Now from here, using our identity, which implies a to the power of minus 1 can be written as 1 over a. So considering this identity, we can put this as x multiplied by 1 over 4 to the power of x, which is equal to minus 1. Then we transform this into this. Then we have x multiplied by 4 to the power of minus x, which is equal to minus 1. From this step, we multiply both sides by minus 1. So if we multiply both sides by minus 1, this expression now becomes minus x 4 minus x 4 to the power of minus x equal to minus 1 multiplied by minus 1, and this side becomes 1. Now from here we can take the exponent of 4. So if we do, we have minus x e to the power of ln of 4 into brackets now be to the power of minus x, and that is equal to 1. Let's multiply both sides by ln of 4. So we have ln of 4 into brackets minus x into brackets e to the power of ln of 4, then into brackets minus x equal to 1 multiplied by ln of 4. So we just multiply ln of 4 to both sides. Then we have that to become minus x ln of 4 e to the power of ln of 4 and minus x equal to ln of 4. So writing this properly, we have minus x ln of 4 e to the power of minus x ln of 4 equal to ln of 4. Then this can be rewritten as minus x ln of 4 e to the power of minus x ln of 4 is equal to ln of 2 to the power of 2. Now let's bring this exponent down to the base. We have minus x ln of 4 e to the power of minus x ln of 4 is equal to 2 ln of 2. Now the next step becomes taking the exponents of these 2. So we have minus x ln of 4 e to the power of minus x ln of 4 equal to e to the power of ln of 2 multiplied by ln of 2. Now from here we can rearrange this step as minus x ln of 4 e to the power of minus x ln of 4 is equal to ln of 2 is equal to ln of 2 e to the power of ln of 2. Now what we now need to do is to apply Lambert W function to both sides. Lambert W function implies that Lambert W function of e to the power of a will give us the resulting answer to be a. So if we apply the Lambert W function to both of this side and this side, so it means that this side will now be equal to the exponent of e, and this side will equal to the exponent of e. So and that will give us minus x ln of 4 e to the power of minus x ln of 4 equal to ln of 2 e multiplied by e to the power of ln of 2. So applying the Lambert W function here, we now become Lambert W function into minus x ln of 4 e to the power of minus x ln of 4 equal to Lambert W function of ln of 2 multiplied by e to the power of ln of 2. So putting the Lambert W function give us the next step to be minus x ln of 4 will now be equal to ln of 2. Now from here, we can rewrite this as minus x ln of 2 to the power of 2 equal to ln of 2. We can bring this exponent down to the base. We have minus 2x ln of 2 equal to ln of 2. Now if we divide both sides by ln of 2, we have divided by ln of 2 divided by ln of 2. So this cancels out with this. Ln of 2 cancels out with ln of 2. Then we now have minus 2x equal to 1. So dividing both sides by minus 2, we have divided by minus 2 divided by minus 2. Okay, this we go with this. We are left with x is equal to minus 1 over 2, which proves the second method. Now let's verify this. Verification. From our equation, 4 to the power of x plus x equal to 0 implies that 4 to the power of, into bracket, minus 1 over 2 plus, into bracket, minus 1 over 2 is equal to 0 at x equal to minus 1 over 2. So this gives us 4 to the power of minus 1 over 2, then minus 1 over 2 equal to 0. This minus multiply this becomes negative. So this can now be written as, considering our identity, a to the power of minus 1 equal to 1 over a. So we consider this to rewrite this as 1 over 4 to the power of half minus 1 over 2 is equal to 0. So we write this in a radical form, and that gives us 1 over square root of 4 minus 1 over 2 is equal to 0. Square root of 4 equal to 1 over 2, and that is minus 1 over 2, which is equal to 0. 1 over 2 minus 1 over 2 equal to 0, and that is equal to 0. This proves that the left hand side is equal to the right hand side, and also confirm that x equal to minus 1 over 2 is the correct value of x. Thanks for watching. Hope you love this one. Hope you enjoy it. If you do, please subscribe to this channel, turn on notification bell for future updates, and share this video to whoever is in need of it. Likewise, like the video, and I will see you in another interesting video. Bye for now.